All right, this is the last of the review problems that I'm going to go through and have the solutions for on video. Everything else will just be directly on the actual assignments. So in the problem, they give you this solid disk that you're spinning like a top. And it spins and then it starts to slow down. And just looking through the problem, you realize that, okay, they're asking a lot of stuff about motion graphs. And it looks strange and different, but if you just realize that, hey, these motion graphs are just speed and acceleration, we've done that before, but it's linear speed, but you can treat it exactly the same. There's going to be a little bit about torque and then just general stuff about rotation. So in part A, it tells you you spin it, there's some friction as it's going through, and here's where I'm going to switch over. So it has a graph kind of like this, and it says to graph the angular velocity. And at t equals 0, it starts at omega 0, and at time t1, it gets to 0. And if it's going to be kind of a constant acceleration, the way you would graph that is just by a nice negative slope straight line. So we have that there. And so then we have our angular acceleration. Our angular acceleration is going to be at some negative value. Why negative? Well, because the slope is negative. And so it's going to go straight across there. And because it's a constant, because the slope is constant, that value is constant. And if we really wanted to look at it, you could say, oh, acceleration, if it's constant acceleration, this value should be negative omega 0 over t1, because that's the change in angular speed over the change in time. So that's what that value is right there. So that's how we can approach that problem in a way that kind of moves forward. So then, if we start, so for part B it says to write an equation for that torque, or to find an equation for the moment of inertia. Excuse me. We have to start for the equation for torque. So torque is just, instead of, the net torque is I alpha, just like the net force is ma. So it's the same variables, but angular acceleration, if you remember, is same thing as linear acceleration. It's just change in velocity over time, but the final velocity is 0 in this case, so my angular acceleration is just negative omega 0 over t1. So that gives me a value here. We have our torque, because it's slowing it down, it's going against it. I'm going to have a negative, so we have those two negatives, and if you just rearrange, you get that the moment of inertia is t1 times the torque over the angular speed. So just kind of looking at kind of what those values are. But then in part C, it says for the first half of the time, they are doing the same basic. Let me see, get out of that there. Doing the same basic setup. So I'm gonna start with a similar looking graph. It starts out with an angular speed of omega 0, and it would have gone to here, but at t equals 1/2, so for the first half, it's going to be the same motion. But now they start adding oil onto it. So instead of slowing down, I'm just going to put a little dashed line to show what it would have done. Now instead of slowing down, it kind of curves up here because of the oil. All right, because the oil, it doesn't come to a stop. It keeps spinning. All right, and so that extends the amount of time to where it would end up kind of stopping. And so I look at that and say, okay, we know that for the first half, it's going to be that same value of negative omega 0 over t1. But then here, by adding the oil, you can get to the point where it goes up to 0. Now, they don't tell you enough information to say exactly what happens here, but we know it's going through. So you could have it go just decreasing. You You could have it go to 0 quickly. You could have it do anything like that because they don't give you any direct information. All you really need to know is that the angular acceleration goes toward 0. So I drew it as going to 0 at a certain point. That's why, because it matched my curve as this kind of went to a horizontal line here. So when the slope of that went to 0, this value went to 0. And so that hopefully should give us a decent way to understand that problem.